6.3, writing and naming ionic compounds. When you're naming an ionic compound, the name of the metal is always written first, and it's the name of that element. The name of the nonmetal is the one that's on the second end, and what you do is you're going to drop the ending and change it to IDE. So here are some examples. You will notice the compound Ki. We have the first one is a metal, potassium. The ending, well, I is iodine. However, when it becomes the ion, we change the ending to ide, so it's potassium iodide. Magnesium bromide. Aluminium oxide. In other words, aluminum oxide. So let's name this ionic compound K2O. Well, K is potassium, and oxygen we change the ending to ide. So potassium and then oxide. Write the names for the following compounds. Press pause and come back. So we have calcium oxide. B is aluminium sulfide. Sulfur is changed, the ending is changed to ide. Magnesium chloride. So let's write the formulas and names for compounds of the following ions. Okay, so I'll do the first two, and then I want you to press pause and do the rest. So if I were to mix this positive with this particular negative right here, it's a 1 positive and 1 negative ratio, so it's 1 to 1. The overall charge balances out. So the formula would be NaBr, and the name would be sodium bromide. If on this next one, my sodium and this sulfide ion, notice sulfide is sulfur until it becomes an ion, and in that case we change the ending to ide, sulfide ion, and it's a -2 charge. So we need 2 of these sodiums to balance out the overall -2 charge here. So it's going to be Na2S, and the name is sodium sulfide. Press pause, please do the rest, and then come back. Now you'll notice here that on our sodium +1, with this nitrogen that became the nitride ion, we're going to need 3 positives to balance out this 3 negative. So we write that right here. This 3 tells us that there are 3 of these sodium ions. When we come down here to our AlBr3, our Al3+ ion and our Br negative, we're going to need 3 of these Brs. So that's why we put a 3 down here. The 3's on the bottom, or the numbers on the bottom, represent not the charges, but the amounts of those ions. So we have their aluminium bromide. For our Al3+ and our sulfur 2-, in order to get our charges balanced out, the common denominator is 6. So 2 times 3 positives is a +6. And 3 times 2 negatives is a -6. So a +6 and a -6 equals 0. So that's why you're going to have an Al2S3, aluminium sulfide, or aluminum sulfide. Aln, this is a 1-to-1 ratio because this is 3 positives and 3 negatives. So aluminium nitride. Now transition elements can form, well, with some exceptions, can form 2 or more positive ions. And so they have a variable charge. If they have a variable charge, we have to then identify to people which one it is. And the way we do that is with Roman numerals. And so here are the most common ones that you deal with in this class. So you need to know that copper, iron, lead, and tin can be more than 1 charge. So because they can be more than 1 charge, you have to realize that every time you see one of those, you're going to have to be putting a Roman numeral next to the name if they give you the formula and ask for the name. And you go, well, how do I know which one it is? Well, here's how we do it. So let's go on to the next one. So use the charge on the anion and charge balance to calculate the charge on the metal ion. Okay, well, in order to know, is this copper 2 or is this copper 1, because we know it can be more than 1 charge. Why? Because it was one of the 4 that I just told you needed to know. We look at the partner. Fluorine is a halogen. Halogens, when they become ions, are then called fluorides, and they become all a -1 charge. Because we have 2 times -1 is a -2 overall, which means We need a total of a positive 2. We have 1, so 1 times positive 2 is going to then be able to add up with that 2 times a negative 1 to 0. So therefore, the name of CuF2 is copper 2 fluoride. When we look at our periodic table, you will notice that here's our transitionals. A lot of them can be more than one charge. So here's an exception you need to know. So first of all, silver is always a +1 charge. Always, 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 always. Did I say always? It's always. Whereas the other transitionals, if they're not variable, we're just going to assume that they are a +2 charge, and there's a reason for that. But you just need to just go with the +2 charge, unless we already have told you it's variable, and you look on the chart for that. Now then, over here in group 4A, notice that our tin and lead can be more than one charge, so we're going to have to use Roman numerals for those two. Over here, our group 1A is always a +1, group 2A always a +2. Because they're always a certain charge, they never are used with Roman numerals. So let's name the ionic compound FeCl2. So we first are going to determine, okay, we have iron, and then we have one of them. The chloride ion is a -1 charge. I have 2 of them. So that means that I am going to have an overall +2 charge, and it's spread out over one atom, so consequently we're going to call it iron 2 chloride. Now then, press pause, see if you can name this one. Notice that this is our oxide, and we know by looking at the periodic table that the oxide ion is a -2 charge. Well, I have 2. 2 times -2 is in the overall -4. So if I have a -4 on this side, I need to have a total of 4 positives on the metal side. Well, I only have 1 atom, so that means that this charge has to then be a +4 charge. And so in naming, it's going to be lead 4 oxide. You'll notice in table 6.7 some other examples. And every single time, the first part describes the metal and the second part is the non-metal. Now, see if you can write the formula for tin 2 chloride. Press pause and come back. When we look at this, we know the chloride is a halogen. They are -1 charge. Tin, this is easy. It tells us the charge, 2. We have 2 of the 2. This is a +2 charge, so that means I need a total of 2 negatives over here. Since our chloride ion is a -1, then 2 times that. And that becomes the subscript in our chemical formula. So SnCl2. Okay, write the chemical formulas for the following compounds. Press pause and come back. Let's look at this. I skipped a couple of slides because I wanted to just talk it through. You can go back and look at those if you want. Now, nickel. We know it's a +2 charge because that's what the Roman numeral says. It's a +2 charge. Our sulfide ion is in group 6A. It is a -2. So it's a 1-to-1 ratio. So the formula is NiS. Zinc chloride. Zinc doesn't have a Roman numeral. And you may go, oh my goodness, what's its charge? Well, if it doesn't have a Roman numeral, that means it can only be 1 charge. Go and look and see where it is in the periodic table. It's over there in the transitional elements, and so it's the one that it's in there. It's always a +2, so we don't have to say a Roman numeral. Now then, because it's a +2 charge and our halogen's a -1, we know we're going to need a total of 2 negatives to balance out this +2 charge. Hence ZnCl2. Now iron 3 oxide. Now I'm going to go back just to help you visualize this one. Now, we know that iron 3 is a +3 charge because that's our Roman numeral. Oxide is a -2 charge. We've got to find a common denominator, and when it's 3 and 2, remember, that means the common denominator is 6. So 2 times this is going to give us a +6, and 3 times the -2 oxide would give us a -6. So a +6 plus a -6 equals 0. So those are the subscripts that we're going to use. Fe2O3. In the olden days, instead of using Roman numerals, we used the suffixes ik and us. This was like even kind of almost before my time. We started using Roman numerals when I was going to college, and my professor promised me that we wouldn't have to know these. Well, it is now, it seems to be a billion years later, and in the health professions, they're still using these suffixes. That means the things at the end of the word, ik and us. So because in the health professions, they're still using them, you need to probably still know them. So the ending ik represented the higher charge. And you go, what do you mean the higher charge? Well, if it was the ion iron that could be a +3 or a +2, ik represented the +3 charge. And us always represented the lower charge. So it would be iron 2. Well, the other thing with this is they didn't then just call it iron. They used the Latin derivative of the element. So Fe3, that would mean that our iron here is a +3 charge. Instead of it being called iron 3 chloride, it's called ferric chloride. Why? Because ferric, the ik ending corresponds to the higher charge. Whereas Fe2, iron 2 chloride, would be ferrous chloride. And you go, where does the fer come from? Well, that's why our iron is Fe. That's from the Latin word iron, and it's actually from the Latin word sword. So then you kind of figure out, well, how did the sword, anyway, you can figure that one out. Anyway, so ferric and ferrous are still used in health professions today. I know that naming takes a little bit of practice. So feel free to watch the other videos, the links that I have, but you will need to practice these.